Hi everyone, so welcome back to my channel. Today I'm again here with another topic, and the topic is area of sector and length of arcs. So, of course, if I'm talking about sector and arc, that means I'm talking about circle. So, before we go into into a detail of these area of sector, how do we find area of a sector, how do we find length of an arc? Let us understand about circle. Okay, a little bit information about circle, and then we will start with this area of the sector and the length of the arc. So let's start with a very basic information. That is, of course, this is a circle. So in this circle, the point at the center, okay, or the point at the middle is called the center of the circle. So this point O is called the center of the circle. Next is, I'm going to draw here the next thing, and that is that we call as, I hope you know this already, that we call as the radius. Okay. So here this OA, okay, I'm just going to write down here A. So this OA is called nothing but radius. Now there is one thing that you should know about, radius, like more than one radius. Whenever we talk about more than one radius, we never call that as radiuses. No. There is a plural of radius given, and that we call as radii. So if I'm drawing here another radius, for example, OA and OB, OA and OB will be called as radii. So if you're talking about more than one radius, you will say the word radii. Okay. So here we are having two radii, OA and OB. All right. So remember, the plural of radius is radii. Next is a diameter. Okay. So this will become diameter. Okay. So from A to C, the CA will be called nothing but the diameter of the circle. Now, of course, there should be a way to define this diameter, and that is nothing but we know the relation between the diameter and the radius of a circle, that we simply call as diameter is equal to double of the radius, right? But that information is not enough when we are just saying the diameter is the double of radius. For example, if you'll say the diameter is double of the radius, then this plus this is also 2r only, but that is not a diameter. So there is one thing that you should always remember, that diameter is, of course, the double of the radius, but double of exactly the opposite radii. Okay, it should be exactly opposite to the other one. So for example, here the opposite of OA is OC. That is why OC and OA, they're combining together and we are getting a diameter. But OA and OB will not, like we cannot combine OA and OB and we can say that, okay, it is also R plus R 2R, so it is a diameter. No, because they are not exactly present at the opposite, right? Same with OC and OB, that will not be a diameter, right? Okay, so these are some basic information. Now there are some other informations that I want to give, and that will be, let's just go here. So for that, I'm going to make another circle. Just a moment. So now let's make another circle to understand the next concept, and that is about an arc and the sector, because that is our main topic, right? So this is a circle. Let us understand what is an arc of a circle. Arc of a circle is nothing but a part of a circle. So for example, if I'm taking a part of the circumference of a circle, that is AB. So from A to B, this is a part of a circle, and this part of a circle is called nothing but arc, right? So of course, if this is the part of a circle, then this is also a part of a circle only, right? The blue one. But of course, we can see that the blue one is bigger than the green one, right? Both are called arc only, but because this green one is smaller, this we call as minor arc, and the blue one is bigger. We call this as major arc, right? Okay, so now this is major arc and this is minor arc. I hope you understood what is minor arc and major arc. Now let's talk about sector. So for sector, this is a center, okay? This is the radius. You know that I'm just using my free hand just to save the time. Okay. So of course we have OA and OB, the two radii. Okay. And if I'm talking about the area between the two radii, OA and OB, and the minor arc, okay, So this will be called as the sector. So basically, in general, what is sector? Sector is the area between two radii and an arc. But here, this area is specifically between the two radii and the minor arc. This is called minor sector. What is this called? This is called minor sector. Now let's talk about the area between the two radii and the major arc. So the area between the two radii and the major arc, this is of course again the sector only, but because it is between the two radii and the major arc, it is called major sector. So what is this called? This is called major sector. I hope it is clear what is minor arc, what is major arc, and what is minor sector and what is major sector, right? So in this particular video, we are going to talk on arcs and sector only. So I'm not going into detail because there are some other parts of a circle as well, which I'm not covering in this video. Okay, so let's quickly do some formulas first, and then only we will be taking the questions. So first is we will understand, like we will just see what is the formula of the perimeter of an arc. So perimeter of an arc, sometimes we use the word perimeter, sometimes we use the word length. Okay, so either the length of an arc or the perimeter of an arc. What is the perimeter of an arc? I'm not going to explain here the formula. The reason is, if I'll explain the formula, it will take a lot of time and the video will be very, very long. So if you want really to understand how these formulas have come, you can just let me know in the comment section. I'll make a separate video for that. Here, I'm directly going to write on the formula. So first, we have a circle. We have to find out the perimeter of an arc, right? So this is, imagine the arc AB. So the perimeter of this arc will be given by the formula theta pi r over 360. One second. Theta pi r over 180. Theta into pi r over 180. This is the formula to find the perimeter of an arc. Okay. What is theta here? Theta is nothing but the angle made at the center of the circle by this arc AB. Right? So here, of course, one angle is formed. So let us imagine this angle is theta. Of course, this is our radius only. So that radius is here. Pi, we all know pi is like either you have to take the value of pi as 22/7 or 3.14, and 180 is the angle, right? So this is the formula to find the perimeter of an arc, and the formula is theta into pi r over 180. All right, this is the first formula. Now let us understand how to find the perimeter of a sector and area of a sector. Okay, so for that, I'll again draw the circle first. Okay, I hope it will take the shape of the circle. Anyway. So this is our circle. And of course, I'm talking about now sector. So let us just write down O, this as A and this is B, where AB is our arc, right? And this OA is of course the radius, OB is the radius, and this particular part is nothing but our sector, right? So first, let us first find out the perimeter of the sector. If I'm talking about the perimeter of the sector, of course, I'm talking about, just a moment, and let me increase the width here so that you can actually understand what is this perimeter of a sector. Perimeter of a sector is going to be the length of this arc. Oh, 1 second, give me a moment. So this is the sector. Let me make the sector very properly. So this is our sector, right? This is the radius OA and OB, the radii, and this is the complete sector, right? So if we want to find out the perimeter of the sector, oh, all right, this is happening every time. Let me do something here. Okay, so this is our sector. Now, to find out the perimeter of the sector, of course, we can notice that perimeter is actually the total length, right? So the perimeter of the sector will be OA plus OB plus AB. where what is AB? The length of the arc. And we already know what is the perimeter of the length of the arc. The perimeter is, if this is theta and this is r, it is going to be theta pi r over 180, right? And what is OA? R. What is OB? R. So what is the formula? R plus R is 2R plus theta pi r over 180. So this is our perimeter of a sector formula, right? So the perimeter of a sector formula is 2R plus theta pi r over 180. So if you just remember the length of the r, that is theta pi r over 180, you just have to add 2R in that, right? Okay, let's move to the next, that is area of the sector, right? So the formula for area, just a second. So the formula for area of the sector is simply going to be theta pi r square over 360. Again, I'm directly writing here the formula. If you want to know how exactly these formulas are coming, do let me know in the comment section. I'll be making separate video, right? As I have already said. So area of the sector formula is theta pi r square over 360. This is the formula to find out the area of a sector. So now we know all the formulas. Now we know the basics about sector and arc. Let's go to the questions directly. So our first question is this. To find out the, okay, so first I'll show you the diagram and then I'll tell you what exactly do we have to do here. So the diagram looks like this. So this is our diagram. This diagram absolutely shows a sector of a circle. As you know, it is a sector of a circle. We have the radius given, that is 13 centimeter. We have the theta given, that is 150 degree. We have to simply calculate the area of the sector, right? So everything is given. Let's just write down the given information. R is 13 centimeter. Theta is 150 degree. And now we have to find out the area of the sector, right? So area of a sector formula is, we know already, the formula is theta pi r square over 360. What is theta? It is 150. What is pi? Let's take the value of pi as 3.14. And then r is 13. So there is 13 into 13. And then what is in the denominator? It is 360. Now, of course, this and this will get cancelled. This will be 3 times 5 is 15. 3 times 1 and 12, right? This will get cancelled. 2 times 6 is 12. 2 times 1 is 2. And then 2 times 5 is 10. And then 7, right? So 1.57. Now we cannot, of course, simplify this further. Like we can simplify this further. We cannot cancel it further. So it will actually become 5 times 1.57. 13 times 13 is 169 and then 6 as it is. Now, of course, we can solve this. So I'm not going to solve this here. I'm directly going to write down the answer. So I'll just do this. You can, of course, do the calculation on your own. So if I do 5 times 1.57, 5 times 1.57 times 169. The answer is coming 1326.65 and then of course divided by 6. If I simplify this, that is 1326 divided by 6. The answer is coming 221.10833, right? So you don't have to do these many calculations, of course, because you won't be having the calculator. You can only solve till 2 digits after the decimal. So 221.10. That's the answer. And of course, it is centimeter square. So this is the answer of our first question. Let's move to the next question. So this is our next question. Here also we have given the radius. Okay, we are given the radius, that is 10 centimeter. We are given the length of the arc. That means we are given actually the perimeter of the arc. So I'm not writing this, that is L only, 15 centimeter. What do we have to do here? We have to find out the value of theta. So theta is unknown, that we have to find out. So let's solve this. Of course, we know what is the perimeter of the sector. right? One second, let me just confirm. Yeah. Okay, so first we will, here in this question, we have to find out theta as well as we have to find out the area of the sector. Both the things we have to find out. So let's first find out the theta, then only we can find out the area of the sector. So perimeter of arc, we know what is the formula of perimeter of arc. Perimeter of an arc formula is theta pi r over 180, right? Perimeter of the arc is given 15. Theta we have to find out. Pi, let's write down that as 3.14. And radius is, of course, 10. And then this is 180, right? So, of course, I'll cancel here this and this. So, what is the value of theta? The value of theta will become 15. 18 will get multiplied and 3.14 will go in the denominator, right? So, this is the value of theta. So, if you simplify this, it will actually become this. So, if I solve 15 times 1800, so what is 15 times 1800? 27,000 and then divided by 314. The answer is coming 85.98. So I'll consider that as 86 degree approximately. So the value of theta, we have got 86 degree, and now we need to find out area of a sector. It's very simple. We know the formula of area of a sector. We will simply write down your area, and the formula is theta pi r square over 360, right? Theta is 86 degree approximately. Pi is, let's just write down this as 3.14 only. R is our 10, so 10 into 10 and 360 as it is. Now what I'll do, I'll just cancel this and here I'll write on 100. So of course this will get cancelled, right? So what are we getting? We are getting the area as 86 multiplied 314, that is coming 27,004 divided by 360. So the answer is coming 75 approximately. So the area is 75 centimeters square approximately, because of course theta is approximate value. That is why the area will also be approximate only, and that is the answer, 75 centimeter square. Let's move to the next question. So this is the next question where we have the sector, of course, given OAB. The radius is given 12 centimeter and the theta is given 60 degree. Okay. So here, what do we have to find? We have to find the length of the arc AB. That is what we have to find out with another added information, and that is we have to keep our answer in terms of pi. Okay, that means we don't need to put any value of pi. We will be keeping our answer in terms of pi only. So that means our answer should contain pi, right? So we all know the formula of length of the arc. So the length of the arc formula is, yeah, it is theta pi r over 360. What is theta? 60 degree. What is pi? We have to keep pi as it is. What is r? 12. And what is this? 360 as it is. Of course, this will get cancelled, this will get cancelled, and this will get cancelled. So the length of the arc in terms of pi that we are getting is 2 pi centimeter. This is our answer of the length of the arc. That is 2 pi centimeter. All right, so we are done. This was a very simple question. We just had to write down the answer in terms of pi. Let's go to the next question. In our next question, we have basically given, I'll directly write down here the question instead of drawing the diagram, because now you have an idea of like how a sector looks like. So the radius is given, of a sector, and that is 6 centimeter. Theta is given. What is theta? Theta is the angle made by an arc at the center of the circle, and that is given 120 degree. So radius is 6 centimeter, theta is 120 degree. Now we have to find out here the perimeter of sector. Okay. What do we have to find here? We have to find out here the perimeter of sector. Okay. To find out the perimeter of the sector, first we should know what is the length of or the perimeter of the arc, right? So first we will find out the perimeter of the arc. So perimeter of an arc, of course, we know the formula. So first we'll find the perimeter of the arc and then only we can find out the perimeter of the sector. So perimeter of arc will be by using the formula theta pi r over 180. Theta is 120. Pi is, let's take 22 over 7. 180 as it is and r is 120. Sorry, r is 6. All right. So r is here 6. Now clearly this 0, 0 will get cancelled. This 6 times 3 is 18. 3 times 4 is 12. So the answer is coming 88 over 7. This is our perimeter of arc, 88 over 7 centimeter. Let us keep this in fraction only. Now we need to find out the perimeter of sector. Now to find out the perimeter of the sector, of course, we are going to use the formula, and the formula is 2r plus the perimeter of the arc, that is 88 over 7. What is 2r? 2r will be 2 times 6 plus 88 over 7. Now what is 2 times 6? 2 times 6 is of course 12. So this will become 12 plus 88 over 7. Now, if you want, you can just write down this 12 as it is, and you can write down the answer of 88 over 7 in terms of like in decimal. So let's check what is 88 divided by 7. It is coming 12.57. So of course, the answer is coming approximately. So answer is coming 24.57 centimeter. Approx. Okay, this is the perimeter of the sector. All right, we are done with this question. Let's move to the next one. So in the next question, we have to find out the area of the sector. So if you want to find out the area of the sector, the radius is given 21 centimeter. And the theta, the angle made by the arc at the center of the circle, is given 120 degree. And we need to simply find out the area of the sector. Of course, we know the formula of area of a sector, a direct formula. We will use this formula and we'll get the answer. So what is area of What is area of sector? Area of sector by formula, it will become theta pi r square over 360. Okay, this is the formula. What is theta? 120. What is pi? If we take the value of pi, that is 22 over 7. R is 21, so 21 into 21 and 360 as it is, right? Now clearly this will become 7 times 3, 21. This 0, 0 will get cancelled. This will become 6 times 2 is 12. 6 times 6 is 36. This will become 3 times 1, 3. 3 times 2, 6. This 2 and this 2 will get cancelled. So what are we getting? We are getting 22 times 21. And what is 22 times 21? If you simplify this, it will become 462. So therefore, this will become 462 centimeter square. All right, now we can go to the next question.